In this recording, we're going to show you some neat stuff about the relationship between logarithms and elasticity that will again help you see and understand elasticity a little better. So we'll call this logarithms and elasticity. Let's start by looking at the same exponential function that we looked at in the last video on exponential functions and elasticity. A is a positive number, P is price, Q is quantity demanded, and here we have a number alpha, and alpha as a demand elasticity has to be negative. It'll be less than 0. This is a function that's crying to be transformed to logarithms, so let's do that with natural logarithms. Let's compute the natural logarithm of the left-hand side. That's logarithm of q is equal to the logarithm of the constant a plus alpha times the logarithm of price. So we have a relationship between two variables, logarithm of q and the logarithm of p. And now compute this. The change in the logarithm of q per unit change in the logarithm of p. What is that? That's going to be that number alpha. That's the exponent on price in the demand curve. If you look at the numerator and the denominator here, for example, look at the d of the logarithm of q, you'll recognize this as a total differential that we've spent some time on before. What's the logarithm, or excuse me, what's the total differential of the logarithm of q? Well, it's going to be dq over q, or sometimes written this way, 1 over q dq. But if you look at this for a second, one of the things you'll realize is that if I were, for example, to substitute a little delta for that d, that's the definition of the percentage change in quantity back when we were talking about discrete changes in quantity and in price. And the same thing is going to be true for price. We know that d, the total differential of price, is going to be equal to 1 over p dp, or dp over p. So let's write the whole thing out. Here we have d ln q d ln p. That's going to be the change in q over q divided by the change in p over p. And we can do algebra on these. We can find dq dp times p over q. This is a marvelous event because what it shows you is that the derivative of the logarithm of q with respect to the logarithm of p is nothing other than the elasticity of demand. And the way I like to think about it is to realize that this number, d of the logarithm of q, just means that a change in logarithms are percentage changes. This is the change in the logarithm of a variable. So logarithms are really percentage changes, and that shows the simple relationship between elasticity of demand and the logarithmic version of this exponential demand function. turns out to be hugely useful later on, especially in empirical work, where these elasticities can be estimated directly from data in the real world.